Hello everyone, welcome to Make Draft and Strength. Today's session is on loci of points of a slider crank mechanism. So let me explain some basic points about crankshaft mechanism. So you can clearly see there is a crank, it is a rotating part, it rotates in a circular manner to a fixed point, and there is one slider. It is a part that slides back and forth in a straight line, means forward and backward direction in a straight line. Okay, and third one is the connecting rod. Connecting rod, it is a link that connect the crank and the slider, that is a connecting rod. And the frame means what? It is a fixed point or the support. These are some basic points. So how it works? When the crank rotates, it moves the connecting rod which push and pull the slider along a straight line. That is the mechanism. Okay, so in any mechanism, not only crankshaft mechanism, in any mechanism every point moves along its own unique path, and that path is called as a locus of point. Okay, locus of point or the loci of points. Okay, so in slider mechanism, the crank end moves in a circle and the slider moves in a straight line. Either it is horizontal or it's vertical. Okay, and any point in between follow a curve. So the curve traced out by that point, it is known as the locus of point. So let's see how the question may ask in exam. So here in question, the diagram is given itself, that is AB, it is a connecting rod, then OA, it is a crank, then P, there is a point, locus of point is given P. So here the connecting rod AB is 120 mm long, so we have to draw the AB 120 mm, and the crank rod is 40 mm long, means we have to draw a circle of 40 mm radius. Okay, then next the point P is given at 45 mm, means AP is given 45 mm. So how we have to draw the diagram, that how the point P trace a curve when the connecting rod moves. Okay, so that is the loci of points. So let's start our actual construction. First of all, redraw the mechanism first. So we have to draw the circle of 40 mm radius. Then divide this circle into 12 equal parts, because connecting rod AB is given. So for the location of A point, so the point A, it is at 1/12 of the circle. So make sure that you have to divide the circle into 12 equal parts and mark point A. Name the remaining points as A1, A2, A3 up to A11. Then next, take a center A and radius is equal to AB. We have to draw the connecting rod. So connecting rod is given 120 mm. So make sure that it intersect the center line. Next, location of point P. So P is given at 45 mm. AP is given at 45 mm. So mark P at 45. Next step, again take a distance 120 mm in a compass, place metal point on A1 and cut center line and mark that point as P1. Join A1 B1, then mark P1 point at 45 mm. P1, it is a point on a locus of P, and repeat the same procedure for remaining points. So here next what I am doing, taking radius is equal to 120 mm in a compass, place metal point on A2, A3, A4 up to A11 and cut the center line at point and mark that point as B2, B3, B4 up to B11. The next step, join points and draw a line in between A3, B3, then A4, B4, A5, B5 up to A11, B11. Next step, take a distance that is 45 mm in a compass, that is locus of point P distance 45 mm in a compass. Place metal point on A2, A3, A4 and cut the respective line, connecting line, and mark the point as P2, P3, P4 up to P11. These are the locus of points. So the last step, join all the points with the help of smooth curve, so it is a required locus of point P. So hope you like the session. If you like this kind of content related to engineering subject, subscribe my channel so you don't miss out next one. Thank you.